Today we're going to be focusing on some additional capabilities with the Casio calculator, specifically the mode and table functions. We already got into part of the mode. We're going to get into functions 3 and 4 today, and then look at what the calculator can do related to tables. Your next homework assignment is due on Thursday at the beginning of class, and we should finish early today. If you'd like to spend some additional time working on that, feel free. And if you have questions that extend beyond our class time today, you can stop by my office or send me an email and I'll do my best to respond. Any questions related to the announcements or anything else before we get started? All right. How many people have their Casios here today? Good. Excellent. You're learning. You're full-fledged engineers. A real engineer wouldn't go out of the house in the morning without some sort of calculator. You never know when you're going to need to start crunching numbers. So an engineer would forget his calculator or her calculator after forgetting to get dressed. That's like how prepared you've got to be. All right. In the past, remember that we were doing the typical equations. The equation mode, if it's already in a standardized format, it saves you the trouble of typing the equation in. It just, through the pre-programmed formatting of the equations, it allows you to just put the prefix that would be in front of, for instance, like an x squared or an x. And so previously we already did 2x2 systems and 3x3 systems. But today we're going to be using quadratic equations and cubic equations. So just as a reminder, why don't you take your calculator, start it up, and to get into the mode 5, you'd push the mode button and then the number 5, and then it shows you these 4 options for equation solving. And in class last Tuesday we did options 1 and 2. Today we're going to do options 3 and 4, which are quadratic equations and cubic equations. All right, so the format of the equation is when you have a quadratic equation, what you're going to need to type in to the calculator are the prefixes a, b, and c. And it's solving for the roots. In other words, it's going to be solving for what are the values of x that makes the equation equal to 0. Now, in the calculator, it's going to start talking about y. When we look at the roots, after looking at the roots, it's going to tell us a little bit about what the equation would look like if we graphed it. And so when it says the y value, what it really means is the entire left-hand side of the equation. And we'll get into that in just a moment. So we open an editor. Let's try this formula out. Let's try out, so we go into mode, equation, and option 3 is the quadratic equation. And so you'll notice here it has a field for us to type in the a value. And so a is the prefix in front of x squared, and here there isn't any number, and so that means it's just 1. 1, and then equals, we'll move to the next field. So this one where it's asking about b should be -6. And we have to be careful to include the sign of the variable that's there. And so I'm going to say -6 and equals. And finally for c, which is just the constant, in this case it's 4, and equals. And when you press equals again, it will mention the roots. The first root is 3 plus the square root of 5. And if we want that to be combined into a decimal, we can push the S to D button. And then it says the root there is 5.24 approximately. And then it will give us the next root by pushing the equals button again. So do that. It's saying it's 3 minus the square root of 5, so 0.76 approximately. Now when you press enter again, it gives us an x value minimum of 3, And if you press X again, it tells us a Y value minimum of -5. Now just to help you understand what that means, I graphed the equation. And so here on the horizontal axis, I took some input values of X, and then on the vertical axis, I put into the equation, I put those values of X in, and then ended up with, do all of these things to X, what do you have on the left side? So let me write this on the whiteboard just so we have reference to the formula when I have the equation, when I have the graph of it on the screen again. So it's x squared minus 6x plus 4. All right, so here's the graph. Let's take, for example, we have a value of 1 for x. And so if we substitute 1 into x, then we have 1 minus 6 plus 4. And so the result of all of that, as you can see from the graph, minus 1. So if we did that for lots of different x values, what the calculator told us was the minimum y value happens at the x of 3, and the magnitude of the minimum y value is, what is that, about -5. So let's go back through the solution again. All right, so we're just going to leave in the same values that we had before, 1, 6, and 4. So those are the prefixes for A, B, and C. So 1, we have the roots, and then it gives us an x value minimum. So that, it's kind of a poor descriptor for what it actually is. It's the x value associated with the minimum of the entire equation. So it's the x value you should put in to get the minimum of -5. Okay, so here are the roots that we got from the calculator. Here's what it's calling the x value minimum and the y value minimum. And so the calculator is kind of handy because not only will it give you the roots, but you could draw kind of a basic sketch of what the formula is doing graphically by knowing those roots and the minimum points. I mean, you can draw a sketch. It doesn't necessarily have to be perfect, but conceptually you could just say, I know that it's going to have this shape, it's going to cross at the roots, it'll have some minimum, and the minimum point on the curve is defined in the third and fourth data points that the calculator spits out. Okay, so I'd like you to try this. Find the roots and then try doing a basic sketch. It doesn't have to be to scale. You can just in your notes or on a separate piece of paper do a basic sketch of what that would look like. All right, if we've already been in mode 5, all we have to do is push the equal key and it will take us into the editor where we can start putting in the numbers. If we weren't in mode 5 already, we can make sure that we're in the right one that we want to be in. So mode 5, and this is going to be a quadratic equation, so that's option 3. I'm going to put in 2 for A, minus 3, and minus 6. Okay, so you should have gotten the first root to be 2.64. The next root is negative 1.14. The x value of where the minimum is located is at 0.75. And so that tells us side to side where that low point of the curve is going to be. And then the y value that it describes, it says the actual low point on the curve will go down to a y value of negative 7.13. So this is what your sketch should look like. And like I mentioned before, it can be just a conceptual sketch. It doesn't have to be perfectly to scale. But what you can do is identify Where are the crossover points, these roots, where the function itself is equal to 0? And then what is the x value that's your minimum point, and what is the y value that's the minimum point? Ramel. The 0.75, that was the magnitude. Let's go through this again. All right. This is the x value where that low point of the curve is. And so let me go back here to the sketch. So 0.75 is, you can see the lowest point here. This is at 0.75. Let me change this so that we have the major is at that. And I think this will maybe help to make it a little bit more visible. All right. Actually, let me even zoom in more. So I can change our view of things by saying, let's do it from -3 to 3. Zoom in on where the action is. Okay, so I'm also going to put some tick marks in there. All right. So the 0.75 is the lowest point of the curve. All right. Are there other questions? All right. So that's a pretty handy function, and it does a similar thing when it comes to cubic equations. Instead of option 3, we're just going to say option 4. And this time, instead of just defining an a, b, and c, we're going to have to define 4 variables, a, b, c, and d. And in that way, it's going to know what the cubic equation should look like. And so let me illustrate with this cubic equation. I'll bring up the calculator here. I want to know, okay, so mode 5, option 4 for cubic. I'm going to give it an a of 1, a b of -2, c of -1, and then the d of 2. This time it's not going to give me the same graphing help though. It's only going to mention what are the roots. And so here it's telling me the roots are -1, 2, and 1. And so if I was to look at a graph of that function, here's what it looks like. If I just picked a bunch of different x values, and then I substituted those x values into the function, on the vertical axis is the value of the function of x, and then on the horizontal x-axis are the x values that I selected. So I started here. I said I'm going to start with -2, and then in steps of, it looks like I did it in quarter. So this is -1.75, -1.5, -1.25, -1, and so on. So the roots that it reported are the crossover points, where the x values are that we should substitute into the function to make it equal to 0, as it said here. You know, this expression, we're trying to find for what are the x values that makes it true. And so the x values that we found, -1, 2, and 1, if you substitute any of those values into this equation, then you'll end up with the sum of the left-hand side is equal to 0, just as the expression says. So this graph, you can kind of do a sketch of it conceptually, because we know that a cubic equation is going to come from beneath, go up, down, and up again. And the crossover points are those 3 roots that were listed. But from the calculator, it's not going to tell us how high this peak is going to go or how low this peak is going to be. And so our conceptual graph would simply just be something like this, where you're putting in the roots and the curves continue. All right, so let's try that here with this one. I'd like you to try with this equation, so x cubed minus 2x squared minus 2x plus 2 is equal to 0. First of all, find what are the three roots, and then try and do a conceptual sketch of what that curve looks like. All right, so let me see if I get the same thing that you did. I'm going to go into mode 5, option 4 for a cubic equation. The A is 1. The B is negative 2. The C is negative 2. And D is positive 2. And now the x values it gives me are negative 1.17. The next one is 2.48. And finally, 0.69. And so if we wanted to do a real quick sketch of that, then the three crossing points will be, if this is minus 1 and this is minus 2, and here is 1, 2, and 3. Okay, so it's going to be at negative 1.17, maybe it's more like that, 2.48, and 0.69. And so it's going to come down, go up, down, and up again. So that's just sort of a brief conceptual sketch of what it should look like. All right. Any questions about how to use the cubic equation solver? All right. Well, you know, we've been doing graphing, and one of the features that's built in to the calculator is called the table function. And it's handy if you needed to solve for several values. Let's say that you wanted to graph an equation and you needed to know the x and y coordinates in order to do that. You could put it into the equation over and over again, and that would be very time consuming. Or you can tell the calculator that here's the equation I need to solve many x and y data points for, and then you tell it what is the range of input values you want to give it, and then the step, meaning the increments over which you want to have those values calculated. And so that is option 7 when you get into the function, the mode menu. So it's table. And here's an example of the type of function that you could input. And so here on the left-hand side, you can see it's saying the function of x. We could also call that y if we were sketching it. It's just the result of whatever's on the right-hand side of the equation. And we'll be giving it input values of x and the increment that we want to calculate the output. So it helps if you are trying to plot a function. It's a very useful feature. So let's try that for this equation, going through and writing it. Now, unfortunately, we have to get back in the mindset of writing equations because we can't just use sort of the pre-existing format that we have in cubic and quadratic. You know, that nice thing where all we had to do was put the number before, where it was like 1, minus 2, and 2. We can't do that because it really doesn't know what equation we want it to solve. It could be anything, any format. And so that's why we have to type the equation in a little bit more of a lengthy way. So I'm going to go into mode 7 for table. And here's what it's asking. It's asking f of x is what? So the left-hand side is f of x. The right-hand side is going to be x squared. So I'll do alpha x squared. Now I could do squared one of two ways. I could just push this button, or I could do x to the power of, and then I have to use the arrow key to get down out of the exponent. So to save time, I'll just say x squared, and I'm already out of the exponent, ready to say minus 2 alpha x plus 2. So I've keyed in the equation. Now when I press enter, it's going to ask me for another equation. And the reason why is it could, if you wanted, calculate a table that has two different equations based on your input values. So it could give you the opportunity to sketch some pretty complicated figures. But in our case, we're just going to have this one equation that we want it to fill in a table for. So when it asks for the g of x, I'm just going to press enter to skip over that. It's another opportunity for me to put in a secondary equation, but it's not required. Okay, so enter, we'll skip over that. And now here it's asking for the start range. What if I wanted to know what is the result of that equation from -2 until 4 in increments of 0.5. So for start, I'm going to say -2. The end range, I'm going to say 4. And then step, increments of 0.5. Now let's see what it shoots out. Here is a table, and we're going to have to use these arrow keys to scroll through the results. The input x value, the -2, is at the bottom end of that starting range. And you'll notice the secondary, the next x value is a step of 0.5 larger than that. So it starts at the bottom of the range and works upward. And then this next column is the f of x, which is the result of -2 being substituted into the equation that we had. So here was our equation. If you substitute -2 into that, what the table is telling us, then the f of x is 10. Remember how we skipped over a g of x field? Well, here's some blank space in the calculator. If we had given it a secondary function, then it would be displaying the results of the g of x in that area. So we can use these arrow buttons to scroll through and see the values. If it's too small, then you can use this to highlight which one, and we can go down because it's not showing the entire range. Our range was supposed to go from -2 to 4. You'll notice here it's only showing -2, -1.5, and -1. So the rest of it is just lower. So if we scroll down, it'll go all the way to 4. And it saves time compared to if you had put this value into the function and typed it over and over again. Even in the last class period, we found some automated ways to recycle equations over and over again. This is still an efficiency gain compared to what we saw in class last time, doing the table function. So it's pretty handy. So why don't you try that same idea out? Oh, well, all right. Here's the result that we've already seen of that example. And you could use that data to put together a sketch. Now, it doesn't sketch for you. This is not a graphical calculator. But if you had the tabular data and you've got your engineering computation paper, those little squares that are in the paper make it nice to do sketches. You don't have to necessarily even have a ruler handy because the paper is already faintly ruled. All right, so try this one. Here's the equation that we're going to have to type in, x squared minus 6x plus 4. And we want to have at the low end of the spectrum, x equals -2. At the high end, x equals 8. And then steps of 1. All right, just to make sure I'm in the right spot, I'll go to mode 7 for table. We have to type in the equation, so it will be alpha x squared. This time I'll do it the other way. I'll do the power of 2, and then I have to use the arrow key to get down out of the exponent, minus 6 alpha x plus 4. Okay, once we double check the equation to make sure it's right, enter. It's asking, do you have a secondary function you also want to graph? We don't. And the start will be from -2 to 8 with steps of 1, which is fine. And it prepares this table for us. And so that matches what we're hoping for here. So minus 2, the function is 20. Minus 1, the function is 11, and so on. And so if we were to then take that and create a graph on our paper, it would be very simple. All right. Any questions about the table function? Mm-hmm. Let's try that out. Let's do that. All right. A g of x. So let's use, this is our f of x, and for our g of x, let's use this formula. All right, so we're going to have we'll let g of x be equal to x squared minus 2x plus 2. And then f of x, let's have it be, let's see, where's the one we did before? This one, all right. So f of x will be x squared minus 6x plus 4. All right. So here in the calculator, we'll go mode 7. The f of x we're doing is x squared minus 6x plus 4. All right. Now it's asking for the g of x. We'll do x squared minus 2x plus 2. We've seen both of these data sets before. The starting range, we'll do it from minus 2 to 8. So start minus 2 and 8, and we'll do steps of 1. It only asks you for the increment and the range for like one set of x values. And so it doesn't give you the choice of like a different set of input values, because it's going to be calculating just one row per input x value. And so here you can see we're getting the f of x and the g of x. And so if you're doing like three-dimensional coordinates, x, y, and z values, this would be a way to graph in 3D. Is you'd be coming with an input x value. This could represent y, and this function could represent z. Does that answer your question?
Yeah.
All right. Oh, if it would ask for even a third?
Yeah.
No, not that fancy. All right. Great question. Okay, so I do have a brief in-class exercise just to reinforce the concepts we've gone over today. On the front side of the paper, it's using quadratic and cubic equations. On the back side of the paper, I'm asking you to practice using the table function. Once you've got this finished, you can either leave for the day and be sure and set the paper on the chair on your way out, or you can hang out and work on the homework assignment that's due on Thursday.